Hey everybody, Chris Pleibel here with PerfectVision Manufacturing. Also with me today is Scott Stekr, our PE. Today is another video from our 4-part video series introducing a new product that we're going to launch out in a few weeks. In this video, we're going to talk about effective projected areas and why we're thinking about them so much here at PerfectVision Manufacturing. But first, I wanted to remind you, if you didn't see our first 2 videos on U-bolts and structural grade hardware, you might want to check those out to get caught up with everybody else. Also, next video is going to be introducing our new product, so stay tuned for that as well. A big thing that is engineers that are talking about across the country are affected projected areas and why they are so important. And I brought Scott in today to help us out about affected projected areas.
So really, the thing about affected projected areas is it's really anything that the wind can touch. So if you're talking about sector frame, for example, right, the face pipes, the antenna pipes, even down to the crossover connections are all part of the projected area that goes into the mounts. And what this does is an engineer uses that area to determine the force that the wind is going to apply to the structure. And the more you can minimize that or reduce it, the lesser the impact is going to be on the structure, the less tower usage you're going to have, and basically, less EPA equals less mods.
So Scott, we got affected projected areas that are on the tower, on mounts, right? And there's different member sizes and member shapes. How do they affect this whole thing that we're talking about with EPAs?
Sure, so when you're talking anything wind, you have coefficients of drag, and our code takes into consideration different coefficients of drag for different shapes. So a round member has a different drag coefficient, right? Then something that's big and flat like this has basically a coefficient of drag a 2.0 depending on its shape, whereas pipe can be anywhere from 0.8 to 1.2, I believe, based on how long it is. But as you can see, round members are generally better off and fare better than anything that's flat.
So basically, when you're taking a look at the effective projected areas of our mounting solutions, what's one of your major goals to help benefit?
So obviously, the more we can turn to kind of round members, and also the more we can possibly shrink the actual size of what's actually projected out there, the better off the product's going to be, the better off the tower is going to be, right? And we're not going to have to reinforce the tower possibly because we have a reduced EPA.
Gotcha. And so if we're not reinforcing the tower, ultimately we're saving the end customer a lot of money, correct?
Yeah, absolutely. That's always the goal. We the stronger our product is, if we can maintain its strength or increase its strength while either keeping EPA as is or reducing it, that's kind of the target we take from an engineering perspective.
Awesome. So we're going down a path here of using better/stronger hardware, reducing EPAs to come up with a better solution to help the industry out, correct?
Absolutely.
Okay, awesome. Great, thank you, Scott. Thanks for coming out today.
Thanks, Chris.
Hey, next week is going to be our product introduction, so please stay tuned with us next week. Take care.